I made 2 movies that are about 30 seconds in total. One movie is what I think we do when we do things with scale, and the second movie is what I think we actually do, and I use we to not necessarily refer to everyone in this room. I use we to refer to kind of computational, quantitative social scientists. And then I thought I'd talk a little bit about what I think the fix might be. So here's movie 1, which is super exciting. You'll laugh, you'll cry. So if you can tell me what we're looking at, that would be great. So I also got a camera and was like bored on the beach, as you can tell, right? So here we're looking at just like 1 square foot of Earth, zoomed in, really small, right? And zooming out and out and out, and it's hard to see at 1 scale. We see little bubbles and micro things, and we don't really know what we're looking at. As we zoom out, we see the whole thing, and earlier speakers have made a similar point. So we're looking at kind of raw pixels, and there are like little entities in here like bubbles and seashells that we can resolve. The next thing, this is what I think we're actually doing when we talk about scale as social scientists. Okay, and here goes this movie. And I think that's it. And the second one is obviously Oscar-worthy and super exciting. But what the second one is I just took all of the pixels in the first one and averaged them over the entire screen. And in fact, when we make a map like this, like that is exactly what we're doing, right? We're taking all of the people inside of these little areas and we're averaging them. And this is the smallest unit that we can resolve in most countries when we do things with kind of large-scale, national, demographic, and economic databases. And when we say we're doing things with scale with these things, we're often sticking them together or looking at things that consist of these things. And so I think our data is really beige. And sorry. You think I'd know how to work a computer? Okay, so whoops, that's cut off. This says Stan Openshaw. So Stan Openshaw, as others have mentioned, and other people in this room, showed us that when you start to mess with the units over which you aggregate things, you can make any kind of thing you want. What it says down here is Herbert Simon, who's also been mentioned today. Herbert Simon gave us complexity theory and argued that complex systems contain levels within them, contain structure within them. And the word hierarchy is often used to describe those levels because they're sometimes nested, but they're not always nested. In Simon's conceptualization, it was not that one thing controls another, it's that complex systems within them have natural units of organization. And within those units of organization, interactions within a unit are more intense than they are across units. And so that doesn't necessarily mean power and control, it just means we're thinking about interactions. And so there's this huge literature which Mike is a part of and referred to. If you want to feel dumb, you can kind of read the literature on complex networks, a lot of which tries to get at how we identify structure in these large interacting systems. I won't get into it here, but what I will say is that over the course of modern history, sociospatial structures have gotten increasingly complex. That is, if we thought about early civilizations or early industrial cities, we had concepts of neighborhoods. We had a factory and people worked at the factory nearby. There was a lot less spatial interaction at the individual scale in terms of how people traveled in cities, at the economic scale in terms of how interactions happened. And for the most part now, I think we use a concept from that period of time. We use the concept of neighborhoods to describe kind of variation within cities. And we lean on this concept, and that's evident, that's how our data systems are built. As social scientists, we lean on this concept of neighborhoods to describe intra-urban variation. But I would argue that that concept is no longer sufficient and actually kind of falls apart because society is much more complex and interconnected. It's digital, economies are complicated, people are moving in all sorts of ways, and that, in fact, in this kind of complicated, interaction-rich, high-mobility society, it becomes very hard to think about spatial scale because of these interconnections within the systems within which we live. That makes sense? I think one of the problems of big, this is awful. So I think the promise of big data, right? The promise of big data is that it potentially allows us to discover those structures. Absent a theory on what it is cities are made of, or what those spatial units that organize our world as a social scientist, absent a theory on what those are, in theory, with big data, we can discover those things. And that actually, to some extent, is what Mike was getting at, was what are the structures, what are the spatial structures that emerge from this? I think there was this wonderful discussion early on in our field about objects and fields, about how we should represent the physical world. That same conversation never happened for the social world. And I think for social science, scale is not a knob that we should be turning up and down. It is a fundamental ontological challenge, in that kind of quantitative human geographers need to be thinking about how we represent social space, how we represent variation within cities. Just as May was saying, like, it's not about how many restaurants there are. It's about, like, what is this thing? What do you do here? How do you describe this place? And we haven't had that. And so I will end on that. Thanks.
So does anyone have one burning question for Seth before we release him?
In ecology, we work a lot with points, and in geography, we don't necessarily have that luxury. But do you see us getting closer to that with point data?
I think, well, in the last 5 years, I was working in Silicon Valley, where it is a world of points. It is bajillions and bajillions and bajillions of points, whether they're GPS points, which you can identify with a user ID or it's transaction locations, or it's businesses. And so there is a world of points out there as well. I don't think having lots and lots of point data solves that question of what are the things we want to study. We can look at all of this raw data, we can aggregate it up to a city or a country or a geohash, but we don't have a theory or anything to organize it, unlike ecology.